So our task today is to purify by column chromatography this pale yellow liquid, which is hopefully the crude 2-methyl-1-phenylcyclohexanol, by column chromatography. So I've gotten the glass wool sand and silica and the ethyl acetate and hexane that we're going to use for the column chromatography, and a beaker full of pipettes. And we need to get the rest of the glassware out that we're going to need. Some TLC chambers. I'm probably going to make about 4 of those so we can have plenty. A series of 100 milliliter beakers to hold solvent, and I'm going to be making up 100 milliliters of the 8515, so I'll get a 250 out for that. Probably only need about 200 ml beakers. And a column. It looks like a nice, relatively clean and non-broken column. A couple of glass stirring rods. Some watch glasses to cover the beakers, which will have our solvent in them. And I usually have a couple of these 25 milliliter Erlenmeyers around to stick pipettes in. And obviously we need a test tube rack that we will be creating a 5x5 array. So here's the A1 setting. And I'm actually going to make a 5x6 array because it's possible that we'll need to run a few more fractions. And I might as well have them ready. Need my graduated cylinders. So that should about cover everything. There shouldn't be any of that. Where I won't knock them over. So before we run the column, we need to run a TLC on the crude material, and that's too concentrated as is. So I'm going to take a drop of it and dilute it up with some ethyl acetate to make a TLC sample. So we'll just take a little bit of ethyl acetate. Doesn't take very much. And just about 1 drop or so. A little bit in the bottom of the pipette. Yeah, maybe a little bit more than that. That looks like about the right amount. And just swirl that up. So that'll be a suitable sample to use for TLC. And I want to run the TLC in a 95-5 mixture of ethyl acetate and hexane. So the first thing I want to do is to prepare that solvent by measuring out 9.5 milliliters of hexane . halfway between the 0.4 and the 0.6 line. And then making that up to 10 with ethyl acetate. I'm going to pour all of that into one chamber. Put this guy back there to evaporate. And swirl it to mix it nicely so we get a uniform solution. And then I'm going to just evenly divide it among my 4 chambers, so I have 4 identical chambers. With about 2.5 milliliters of solvent in each one. And cap them up tight so the composition doesn't change. I'll just be using one for my initial TLC, but then when I get to TLCing the fractions, I'll probably want additional chambers. So might as well have them ready when we need them. And I also need to make a standard of the starting material, the 2-methylcyclohexanone, so I can identify where that appears. And I'll do that in ethyl acetate as well. That standard would normally be prepared for you. Since I'm in here doing lab by myself, I gotta make it up. Make that up the same way we did the other one, just a little bit of ethyl acetate. This time I'm going to make sure my pipette is actually dry before I stick it in the bottle. So I don't want to introduce any ethyl acetate into the stock bottle of 2-methylcyclohexanone. And then we're just taking that little bit, about that much in the pipette. Mix that up. This guy back. And we'll throw a label on each of those so we know what we're working with. Label this one starting ketone, and this other one with my lot number. And as always, tape those labels on because they don't stay otherwise. So I have my TLC samples. I'm going to grab a plate. And that's on tight. Making sure to handle it just by the edges. And I need a pencil. So we're going to do a co-spot here. Use this end. Where we're going to put the ketone here. Label that K. The product over here and a co-spot in the middle. This one's not UV active, so there's no point looking at it under UV light while we spot it. The ketone's not UV active anyway. Make sure that's nice and flat by pinching it. Yeah, that looks pretty good. I'll just take a little bit of the starting ketone in there. Dab it a few times in each place. Product. The same procedure. Sit that in the chamber. Let that develop. While that's developing, I'm going to get my phosphomolytic acid stain ready. And that stain has to be heated. So we need a hot plate. And we're going to use this kind of hot plate. I'm going to go ahead and do this over in a different hood. So these round hot plates plug in down here. And it's already turned on. And I'm going to want a setting of about 55 or so, or 60, to get that nice and hot. Grab a paper towel, which is what we'll use to wipe the plate off on. And in the refrigerator, we'll get a bottle of the phosphomolytic acid stain. Phosphomolytic acid is a good stain for oxygen-containing compounds like aldehydes and ketones. And what we're looking at here is actually a 20 weight percent solution of phosphomolytic acid in ethanol. So 20 grams of phosphomolytic acid to 100 grams of solution. And that'll react with compounds that are capable of reacting with phosphomolytic acid and create blue or sometimes orange for ketones spots against a pale green background. So we'll use that, and we'll need a pair of forceps to handle the plates in there. So that'll be ready when we need it. So while I'm waiting for that TLC to develop, I'll grab a little bit of this glass wool. And we want to shove that down into the bottom of the column, for which I'm going to use the back end of a thermometer, being careful not to break the thermometer. Yeah, it looks like it's a little too much glass wool, actually. Kind of hard to get that down in there. The purpose of the glass wool, of course, is just to prevent the sand from going out the edge, and that's not behaving itself. Not able to get that to go in properly. So take some of that away. Wad that up a little tighter. It's got to fit tightly into that hole. That's better. Oops, that clamps on the wrong direction. Because I'm right-handed. So we're going to clamp that column about halfway up with the label up front so we can see it. And we want to make sure that it's above the test tubes and that the test tubes are able to freely move underneath it. Maybe raise that just a little bit so that we'll be able to move that back and forth. So, no problem. And we're going to cover that glass wool with a little bit of sand. Doesn't take very much. A little bit more. I usually try to use enough sand to get it into the uniform cylinder. And I'd like a beaker that's actually graduated to make the column in. Take a look at that TLC, seems to be behaving. So I want between 30 and 35 milliliters of silica gel to give me about the right size column. I'm going to err on the side of having just a little bit more than 30, maybe 30, 34, 35.